NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will learn how to analyze the sign of a quadratic expression by completing the square. Here is our plan. Start with the general form, complete the square, rewrite using the discriminate, and then read the sign from a simple number line picture. Start with the general quadratic trinomial p equals ax squared plus bx plus c. We will also use the discriminate capital delta, defined as b squared minus 4ac. To complete the square cleanly, we first factor out the leading coefficient from the x terms. So p equals a times the quantity x squared plus b over a times x plus c over a. Now complete the square inside the parentheses. Add and subtract parentheses b over 2a squared, which is b squared over 4 squared. This does not change the expression, but lets us form a perfect square. Collect the first three terms as a perfect square. That becomes x plus b over 2a squared. Then combine the constants, negative b squared over 4a squared plus c over a. Put those constants over a common denominator 4a squared. The result in the brackets is minus b squared minus 4ac over 4a squared. That numerator is the discriminate, delta, so we write p equals a times the quantity x plus b over 2a squared minus delta over 4 squared. This form is powerful. The vertex sits at x equals negative b over 2a. If delta is non-negative, roots are x equals negative b plus or minus the square root of delta all over 2a. In this lesson, we will perform a sign analysis of a quadratic expression, focusing on the case where delta is less than 0. First, let's show the example label and the problem statement clearly on screen. Step 1. Write the quadratic in its completed square form. This form separates the coefficient a and the discriminate, making the sign analysis very clear. Step 2. Focus on the case where the discriminate delta is less than 0. We'll state the condition clearly, and then examine the term inside the brackets. Step 3. Analyze the bracketed term. The square part is always non-negative. Because delta is negative, minus delta is positive, so the entire bracket becomes strictly positive for all real x. That is the key to the sign of p. Step 4. Conclude the sign of p. Since p equals a times a positive term, the sign of p is exactly the sign of a for every real. Sign of p is exactly the sign of a for every real x. Let's summarize this in a quick sign table. Step 5. Apply the note for the two possibilities. If delta is less than 0 and it is positive, p of x is greater than 0 for all real x. If delta is less than 0 and it is negative, p of x is less than 0 for all real x. These pictures make it intuitive. The parabola never meets the x-axis, and it always stays above or below depending on the sign of a. Final answer. When delta is less than 0, the quadratic has a constant sign across all real numbers. It matches the sign of a, positive if it is positive, and negative if it is negative. In this lesson, we analyze the sign of a quadratic expression in the special case when delta equals 0. Our goal is to see, visually and algebraically, why the sign of the quadratic matches the sign of the leading coefficient everywhere except at a single point where it equals 0. Let p of x be ax squared plus bx plus c, and let delta be b squared minus 4ac. By completing the square, we can rewrite p of x as a times the square of x plus b over 2a minus delta divided by 4 squared. In the special case, when delta equals 0, this simplifies beautifully to p of x equals a times x plus b over 2 all squared. Let's see it on a graph. Here is the example p of x equals the square of x minus 2. This is a parabola opening upward that touches the x-axis exactly at x equals 2, and it stays above the x-axis everywhere else. That shows p of x is never negative, which matches the fact that it equals 1 is positive. The algebra agrees. Since a squared quantity is always non-negative, a times the square has the same sign as a. It equals 0 only at x equals negative b over 2a. Here is a compact sign table when delta equals 0 and is positive. On both sides of x equals negative b over 2a, the quadratic is positive, and it is 0 at that single point. What if it was negative? Consider p of x equals negative the square of x minus 2. the parabola opens downward and stays at or below the x-axis. It is never positive. Again, p of x equals 0 only at x equals 2, and its sign matches the sign of which is negative here. The sign table for delta equals 0, and a negative shows p of x is negative on both sides of x equals negative b over 2a, and equals 0 at that single point. In this lesson, we will analyze the sign of a quadratic expression when delta is positive. We start with an example statement on screen. Step 1. We start from the standard form p equals ax squared plus bx plus c. By completing the square, we can rewrite p in a vertex-like form. We will focus on the case where delta, that is b squared minus 4ac, is greater than 0. Step 2. We recognize a difference of squares pattern. Rewrite the expression inside the brackets as a squared minus b squared, then factor as a minus b times a plus b. Step 3. Set p equal to 0 and solve for the two real roots, which occur because delta is positive. We obtain x1 and x2. Step 4. We analyze the sign of the quadratic expression by looking at intervals on a number line. First, when it is positive, the expression is positive outside the roots and negative between them. Next, when it is negative, the signs reverse, negative outside and positive between the roots. Step 5. The general rule is simple. Outside the roots, the sign of p matches the sign of a. Between the roots, the sign is opposite to a. In this lesson, we will analyze the sign of a quadratic expression and verify the result with its graph. The expression is p of x equals negative x squared plus x plus 2. Our goal is to determine where p of x is positive, where it is negative, and confirm using a graph. Step 1. Set the expression equal to 0 and factor. First, write negative x squared plus x plus 2 equals 0. Factor out negative 1 to simplify the trinomial. Factor the quadratic x squared minus x minus 2 equals left parenthesis x minus 2 right parenthesis times left parenthesis x plus 1 right parenthesis. Using the zero product property, the roots are x equals negative 1 and x equals 2. Step 2. Make a number line to reason about the sign. Mark the critical points at x equals negative 1 and x equals 2. Because the leading coefficient is negative, the parabola opens down, so the sign is negative outside the roots and positive between the roots. Step 3. Summarize with a compact sign table. At x equals negative 1 and x equals 2, p of x equals 0. It is positive between the roots table. At x equals negative 1 and x equals 2, p of x equals 0. It is positive between the roots and negative otherwise. Step 4. Verify with the graph. Draw axes, and the parabola y equals negative x squared plus x plus 2. Mark the intercepts at x equals negative 1 and x equals 2. Notice the curve is above the x-axis between the roots and below outside the roots. Final answer. P of x is greater than 0 for x between negative 1 and 2. P of x is less than 0 for x less than negative 1 or x greater than 2. P of x is less than 0 for x less than negative 1 or x greater than 2. In this example, we will perform a sign analysis of a quadratic expression. The problem asks us to determine where the polynomial is positive, 0, or negative, and then verify our sign table using the graph. The polynomial is p of x equals 2x squared minus x minus 3. Step 1. Calculation of roots. We first set the polynomial equal to 0. Compute the discriminant delta, which is b squared minus 4ac. Now, apply the quadratic formula to get the roots. The roots are x1 equals 3 halves and x2 equals negative 1. Step 2. Create the sign determination table. Since it equals 2 is positive, the parabola opens upward. The sign pattern for p of x will be positive outside the roots and negative between the roots. We mark the exact zeros at x equals negative 1 and x equals 3 halves and fill in the signs accordingly. Step 3. Verify with the graph. We draw axes and plot y equals 2x squared minus x minus 3. Mark the x-intercepts at negative 1 and 1.5. Observe that the curve is above the x-axis for x less than negative 1 and for x greater than 3 halves and below the x-axis between the roots. This perfectly matches our sign table. Final check and summary. The sign pattern is positive, 0, negative, 0, positive across the real line at the roots -1 and 3/2. The graph confirms these intervals exactly. Therefore, p of x is positive for x less than -1, and for x greater than 3/2 equal to 0 at x equals -1, and x equals 3/2 and negative for x between them. In this example, we will perform a complete sign analysis for a quadratic expression and verify our results using the graph. Step 1. Set p of x equal to 0 and factor. We look for two numbers that multiply to +2 and add to -3, which are -1 and -2. So the factorization is left parenthesis x minus 1 right parenthesis times left parenthesis x minus 2 right parenthesis equals 0. By the zero product property, the roots are x equals 1 and x equals 2. Next, let us draw the graph to get intuition. Since the leading coefficient is positive, the parabola opens upward. We mark the intercepts at x equals 1 and x equals 2. Then we will shade intervals to show where p of x is positive or negative. Now, let us build the sign table. We split the real line by the roots into intervals, from -∞ to 1, exactly at 1, from 1 to 2, exactly at 2, and from 2 to +∞. Since the parabola opens upward, p of x is positive outside the roots and negative. In this lesson, we'll perform a complete sign analysis for the quadratic expression p of x equals -3x squared plus 4x minus 1. We'll find the zeros quickly using a smart coefficient trick, build a sign chart on a number line, and confirm everything by graphing the parabola. Step 1. To find where the sign of p changes, we start by solving p of x equals 0. That is, -3x squared plus 4x minus 1 equals 0. Here is a quick check. For a quadratic ax squared plus bx plus c equals 0, if a plus b plus c equals 0, then the roots are x equals 1 and x equals c over a. Let's compute. -3 plus 4 plus -1 equals 0. So the trick applies. That gives us the roots x equals 1, and x equals -1 over -3, which is 1/3. Step 2. Let's build a number line sign chart. With roots at 1/3 and 1, the sign of p can only change at those points. Since the leading coefficient -3 is negative, the parabola opens downward. That means p of x is negative outside the roots and positive between them. Step 3. Let's confirm our sign chart by graphing y equals -3x squared plus 4x minus 1. A downward opening parabola should cross the x-axis at 1/3 and at 1. Above the x-axis, the function is positive, and below the x-axis, it is negative. Final conclusion. The sign chart and the graph agree. P of x equals -3x squared plus 4x minus 1 is positive on the open interval 1/3 to 1, and negative on -∞ to 1/3, and on 1 to infinity. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.